Today we're going to go over two questions. The first question I am going to go over is to do with the question we can see here. Now, it would like you to first of all write down an equation for the area A of the curved surface area. Now, the first thing I would do for this particular question would be to go to the formula booklet and find what the curved surface area is. The curved surface area is going to be this section of the cylinder, and that's simply going to be 2 pi r h. If you'd like me to explain why, please contact me. Now, this question specifically says it wants you to write it in terms of r. This means we do not want any unknowns other than r. So r is okay, 2 pi is fine because it's a number, and h, we want to get rid of it. The way we get rid of h is by using the second statement of the question. The sum of r and h for this cylinder is 12 centimetres. So what we do is we write a mathematical equation here, r plus h is equal to 12, and we want to rearrange to write this in the form of h equals something. And this is because we want to eliminate the h from the original equation. So we rearrange the equation, now we have h is equal to something else. So now we're going to substitute equation 2 into equation 1. We get the following: 2 pi r, and instead of writing h, we're going to write 12 minus r. And to get your final mark, you need to expand this single bracket. We do 2 times 12 is 24 pi r. Then this one is r times r, which is r squared, 2 pi. That's it. We have got our function and we've written it in terms of the curved surface area A. That would be our full 2 marks. Step B would be to differentiate it. Now, in order to differentiate a function, let's say we've got a function where we have a is equal to r squared plus r. Now, when you differentiate this particular function, r squared plus r, we are going to say we're going to differentiate a with respect to r. So we put the capital A, the number that or the letter that's on its own, or is the subject of the formula, divided by or differentiated by d of r, differentiated with respect to r. So what we do is we take the power in front, so it becomes 2r, and reduce the power by 1. For the r itself, it just becomes a 1. Effectively, it becomes the number in front of the r, and this is just a 1r, so this is differentiated to a 1. Now let's apply this same principle, but for question B. Now we take our function, we write dA of dr. Now if it ever says dA of dr, or another way it could say it would be a dash, this just means you need to differentiate a. So a dash or dA by dr is the exact same thing. We take the coefficient in front of this term, 24 pi, and write that down, because this is just to do with r times a coefficient, and then this one is r squared. So we take the power of 2 down, it becomes 2 times 2, which is 4 pi r. That is it, we've differentiated it. Now we're going to go over part C. Now there are 3 separate methods for this. 1 manual method and 2 on the calculator. Let's go for the manual method. It says, find the value of r when the area of the curved surface is maximised. Now, if it ever asks you to maximise or minimise, what you need to do normally is set up an equation with another equation, substitute one into the other. You then will differentiate this function, and then for the step where it asks you to maximise or minimise, you need to set this differentiated equation equal to 0. So we've got 24 pi minus 4 pi r equals 0. And there's a complex reason why, and I will explain it in the next part of the video, but not quite now. We want to find the unknown, which is r, so this is just a simple solving equation. So we do 24 pi equals 4 pi r, then we're going to get r on its own. We need to take the 4 pi to the other side, or do the inverse of it, which is divided by 4 pi. So I'm just switching them around before I do that. 24 pi divided by 4 pi equals 6, because what happens is the pi's cancel. 24 divided by 4 is 6. That is the easiest way to do this question. And there are several reasons why we would do the question like this. First of all, I'm going to now talk about another two methods of doing this by firstly focusing on this function, the original function. Now, if I was to draw a sketch of the original function, I know it's going to look a bit like this. It's a quadratic graph, so it will have this shape. It's also going to cross at 0 because the function itself has got no coefficient on its own. And as well as that, we know it's going to be an unhappy face or a negative parabola because the number in front of the r squared is a negative number. So with this graph, if we want to generate something which is called a maximum, this is because it wants you to work out what the x value is when this occurs. That's easy. Now, another way of doing this is to deal with the differential function. So if we dealt with the differential function and sort of thought of a dash is representative of different things. Now, a dash can be a bit confusing to explain, but let me explain what the gradient means itself. When we differentiate something, this gives you the gradient of the tangent. So this is a gradient, this is a gradient, this is a gradient, etc. Now, when the gradient, which is also dA of dr of this, is equal to 0, we will also generate when we get a maximum or minimum. So there's two things you can do. You can either find the max or min of the original function a, or you can find what we call a 0 of a of dash, and that will give you the same answer. Let's go over that. On our calculator then, we are going to type in the original function. Our original function is going to be 24 pi r, we write an x instead of an r, minus 2 pi r squared. Now, we're going to press graph. You can see a little bit of the quadratic graph, but the quadratic graph is going to be massive because we can only see a section of it. And when it looks like a straight line, that means we need to amend the windows to make them a lot bigger. So let's change x max to 500, y max to 500, and hope for the best. Now we can see the graph is here, so clearly we've gone too large. Let's go down to 200. Now we can see part of the graph, but not the full graph. So I'm going to squash in the x, but increase the y. There we go. We have got a quadratic graph. I've still got a little bit too much of the x-axis, so I could change that a little bit. Let's change x max to 25. This will take you a long time, but it's worth it. Now, to find the maximum, you press second calc. We go down to maximum, which is number 4. We select the left bound, right bound, centre. Make sure you know your differences between your lefts and your rights. Left bound, right bound, and then centre. Press enter. It's going to give us our maximum is x is 6.00. And because I said we need to find the x value, this x value in this question is r, so r is 6. So that is the second method of doing it, but I still think that the manual way like this is easier. Now the third method is to take your differential function. Now the risk of doing this question is that you could have typed it in wrong, or you could have got it wrong in the original question. Our differential function is going to be, let me have a look at where I wrote this answer. 24 pi minus 4 pi r. So 24 pi minus 4 pi r. Let's press graph. Now this is different. We're looking for what we call a 0. Now a 0 is when y is 0 or when a is 0. And this is a bit like solving the equation for 0. So you just press second calc, 0. Number 2, we're going to go above and below the x-axis, which is the horizontal line. We're going to go above. At the moment, I cannot see very much, so I'm going to press window and I'm going to make sure I can see more of the y minimum. Minus 10, let's press X. We can see a little bit more. Let's change it again. Let's go to minus 20. Press graph. Excellent. Second calc. Then we're going to press 0, which is number 2. When we get to this, what we're going to do is we're going to select the top bound, the bottom bound, and then the centre. It's just a bit above. Then we're going to go below, and then we're going to press centre. And the 0 is at 6, 0. So that also generates an r equals 6. So 3 methods of doing the same question. Now let's go over the next question. Here are some answers. We are going to go over it in a bit of a neater manner. Right, so the question is here. It's a function. The first thing I would do with any function question is go onto the y equals and type in the function. We're going to type 1/3 x. I do this using brackets and the division symbol, 1/3 x cubed, so it's the power of 3. Then we're going to put plus 3 divided by 4, x to the power of 2. Then we're going to press minus x minus 1. Then we're going to press graph. Now, because it's a cubic graph, we're going to expect local max and min. Later on in the question, it asks us to change the window because it says sketch the graph for these values. So we're not going to change the window yet, but it's in our calculator ready to go. Find f of 2. The easiest way to do this is press second table and to go when x is 2. When x is 2, y is 2.666, or to 3 significant figures, 2.67. This is just substitution. You could manually substitute without the calculator. Write down the y-intercept of the graph. The answer is -1. Please remember that the answer to this will be the number on its own. The number on its own is always the y-intercept. If you don't remember that, you're a little bit silly. But if you really, really can't remember that, you're going to go to graph, you're going to press a second calc, and you're going to go on to value. Value is when x is 0, which means when x is 0, which is where the y-axis crosses through, it'll tell you what the y-intercept is. Y is -1. So rather than this being a 0 like the previous question, this is going to be a value question. So we press second calc, value, x 0, enter. Right. Next part is to sketch the graph. So it wants you to change the window. So we go on to window. We're going to change it between -3 and 3 and -4 and 12. Make sure you're using the small minus. Then we'll press graph. Then what you've seen here is that I've completed this question earlier. Let's have a look at how I completed it. This question here is the image of this graph we can see. This particular graph, we can see it has a maximum. This maximum is closer to the outside of the graph more than the y-axis. This minimum is normally equidistant between the both of them. And also we can see that on the screen that the minimum and the maximum are a lot lower to the, or a lot nearer to the bottom part of the graph rather than the top part of the graph. That's the kind of thing you get marks for. So let me run over the marks. Mark 1 normally is for drawing a general shape and labelling x and y axes. Mark 2 and Mark 3 would be for things such as drawing the max and the min and their proximity to different parts of the graph. Now, Mark 3 and Mark 4 would be to label specific parts of the graph. So we could label the y-axis as -1. We could find out what the max and the min is. And now this is easy. So we press second calc. We're going to find the maximum, which is number 4. Then we're going to select the left bound, right bound, centre bound. Left bound's here. Right bound, centre. It says -2, 1.3 recurring. So what I would do on the diagram is label -2, 1.3 recurring. Now we're going to find the minimum. Second calc, minimum. Number 3, we're going to move the cursor along towards the minimum. Then when we approach it, we're going to do exactly the same process. Enter to the left, enter to the right, and enter in the middle. And it gives us 0.5 minus 1.208. So this one is not so significant because the numbers aren't very nice. It might say in the exam, can you show key features? You might only have to show the maximum. But if you've got time, show the max and the min. Show the one that's the most clearest on the diagram. And on this particular diagram, the max seems like a more clear-cut maximum. Let's continue with the question. Find f dash of x like we talked about before. This just means to differentiate. So you're going to move the power down. So it becomes down, and then it's 3 over 3, which is 1. So it becomes x squared. This one you move the power down. It's going to be 3 times 2, which is 6. 6 over 4x. The minus x becomes minus 1, and then the minus 1 itself, the number disappears. Find the gradient of the graph of y of f of x at x equals 2. Now, again, there's lots of ways of doing this, but this is asking to do with the gradient. And because it's a gradient, we're going to use the f dash of x function. And we are just literally going to substitute 2 into the previous function. So we get 2 squared plus 6 over 4 times 2 minus 1, which is 4 plus 3 minus 1, 6. That's really quite straightforward. Again, you could use the table function of your graph on your calculator if you'd like to. Let's go on to y equals, let's type in x squared. We're going to type x to the power of 2 plus 6 divided by 4, or 3 divided by 2, x minus 1. Then what we would do would be to press table, second table. And when x is 2, we've got the gradient is 6. That's another way of doing it. There's a third way of doing it, which I've written on the help sheet, but that's even more complicated. Find the equation of the tangent line to the graph at y equals f of x at x equals 2. Now, this is where it gets a little bit complex. Let's say we've got an image of our original graph. Our original graph, like we've drawn, looks a bit like this. Now, when x is 2, I'm assuming it's going to be around about here because this is 0.5. By my image, it's going to be up here. And we know the gradient's positive. So this is the particular gradient at this point. At x is 2. We have a gradient of 6. We've already calculated that already. But it's not just asking for that. What it's asking for is at this point where x is 2 and the gradient is 6, what's the equation of this straight line? So what we're going to do is the following. We are going to write down y equals mx plus c. Now, the gradient is 6, 6x plus c. We now need to substitute in a point. Well, we know the point is going to be 2 for the x, but we don't know what the point is going to be for the y. So we do know what the point is going to be for the y because actually looking at the previous question, we've already substituted into. Now, this is connecting all the parts together, and we got y was 2.67. So this coordinate here is going to be 2.67. So we are going to substitute this into this equation at the bottom here to work out what c is. We're going to have 2.6 recurring equals 6 times 2 plus c. 2.6 recurring minus 12 equals c. Then we're going to minus 12 from this. It's going to be 2.6 recurring minus 12. Not sure off the top of my head, so I would go onto the calculator. Minus 2.6 recurring, and it's actually not going to be minus 2.6, it's going to be positive 2.6 recurring. I'll write a few 6s after it. Minus 12 is minus 9.3 recurring. So C is minus 9.3. And then combining it all together, we have y equals 6x minus 9.3. If you wanted to write that as a fraction, that's absolutely possible. And what you can do is you can press math and then you can press the number 1, and then it'll change the answer into a fraction. That's minus 28 over 3. That's quite a nice fraction. That's probably correct. The function has one local maximum at x equals p and one local minimum at x equals q. We can tell that because we've got a maximum and a minimum here. Use the derivative of f of x to find the value of p and the value of q. Now, there's a couple of ways of doing this again, but it's asking us specifically to use the derivative. But I think in your exam, it'll give you a couple of options of how to do this. Effectively, what we want to do is solve the derivative, x squared plus, I'm going to simplify this to plus 3 over 2x minus 1 equals 0. Now, you could manually solve this, but this is more difficult. So you could manually solve it on a calculator. And this is a fourth method of solving the derivative when it's equal to 0. If it asks for maximum or minimum, you need to set the derivative equal to 0. You either manually solve, you use the two methods we used on the previous example, or you can use this method. We're going to go on to apps. On apps, we are going to go on to polysmelt, number 3. We're going to press any key. We want to find a root finder, which is number 1. There is going to be an order of 2. Basically, it's given us a quadratic equation here, which we've got to fill out. X squared is just 1x squared, so we put 1x squared. A1 is 3 over 2, which simplifies to 1.5 or changes to a decimal as 1.5. And then the A0, the number on its own, is going to be negative 1. We just press solve. And it gives us the two solutions. X is equal to minus 2 or X is equal to a half. So, because we can tell from the maximum and the minimum, we're going to have two x values. The maximum x value is going to be the smaller number. So using this calculator, we're going to say that the max value, which occurs at x equals p, is equal to minus 2 because it's generated at the smallest value. And then the min, where we've got x equals q, is at the other value, which is 1/2. If you don't like this method, I'll just remind you of the previous method. All you need to do is you go back to y equals, you're going to put in the original function because we want to find the max and min of the original function. Although the question is asking you to use the derivative, so this might not be possible. We're then going to take x, we're going to take it to the power of 3, we're going to plus 3/4 x squared minus x minus 1. We're going to press graph. We're going to change the numbers like we did before, minus 3, 3, minus 4, 12. I believe that's already correct. And then we're going to generate the max and min. We have actually already worked them out here. We worked them out to be minus 2 and minus 0.5. So I already did that in a previous question. So you can tell that these answers are correct from the previous question because they now match with this part here. So the range for P to Q is just substituting the minus 2 and the half into the question. So we have minus 2, then x, and then half. That just basically means if we wanted to study the range between the max and the min, it's going to be any x value between minus 2 and a half. I hope you found that video useful. Let me know if you've got any questions.